All right, the 2014, sorry, yeah, 2014 calculus exam for NCEA 2, question 2a. Now, we've got to draw the gradient function. There is the function. Underneath, we're going to draw the gradient function, although I'm actually going to superimpose it over the function so you can see how the two relate. Now, at a very basic level, you can draw this very simply and get the marks. However, if they want more than the basics and you're not quite sure just how much they want, you'd be well advised to be able to add as much detail as you can to make sure you get the marks. All right, so first of all, on the most basic level, let's do it the easy way and do no detail other than the very, very bare minimum. We can see the turning point is here, therefore the gradient is 0 there, therefore the gradient value, the value where the gradient is 0, is going to be this one here. This is going to be a -3. So, and we're also looking at the gradient here, the graph here, this is basically a negative parabola, which means we can represent it with a negative straight line. And the negative straight line can be anything as long as it goes through this point here. So you could just basically draw a line straight through here, make it negative, and they're not going to worry too much about where it cuts the x-axis or the y-axis, other than it must go through there. So it must go through the x-axis there, y-axis wherever it does. But I think that's a mistake because it's very, very clear where this actually does go. And if we look at this parabola here, we can see it is a fundamental parabola. It is basically of the type y is equal to -x squared, but it happens to be 6 up. It also happens to be 1, 2, 3 across. So this is going 1 along, 1 down, 2 along, 4 down, 3 along, 9 down, 9 down. So this is in fact a basic parabola like this. And if we were to differentiate this type of parabola, not this one, but this type of parabola, we're going to end up with -2x. So the gradient of this must be 2x. So -2x, so it's going to be 1 along, 2 down, 1 along, 2 down, 1 along, 2 down. And it's going to essentially go through this point and this point here. So I'm going to try and get this as good as I can. Let's have a look. Is that about right? That looks pretty good. Okay, so I'll draw it straight through. I think that's good. Yeah, so again, you don't want to miss points. You want to try and show that it goes through hits various points as it goes through. So this is going to be 1 along, 2 up, 1 along, 2 up, 1 along, 2 up. And it does seem to be going through those points there, which is great. So this is a -3. And you could actually draw the function of this. You could say f dash x or f prime x is equal to, now in this case, it's going to be -2x, and it's going to cross at, in this case, look at it here, is -6. So it must be, the y-intercept must be -6, and there is the gradient. Where's the function? Other ways you could do it, of course, is you could actually work out the function of this thing here, which is not that tricky. Let's go ahead and do that. By the way, that's all you need to do, maximum. That's the maximum you need to do. But let's just do it another way as well. I tend to like to find the parabola here. Well, the parabola goes through a 0 here and a -6 over here. So it's going to be y is equal to x plus 0 and x plus 6 here. Now that's the nature of the parabola. You could use an a in front here, but you can see it's 1 along, 1 down, 2 along, 2 down, 4 down, 3 along, 9 down. So you don't need to do that. But if you wanted to, you could. But otherwise, you could say y is equal to, and we know it's negative, so we must put a negative there, -x times x plus 6. So y, therefore, is equal to -x squared minus 6x. So if we find the differential of that, dy dx, is going to be negative, oh, sorry, what am I doing? That's going to be 2x. I'm actually jumping ahead here. I'm actually thinking, what will the differential be? Well, let's differentiate. It will be -2x minus 6. There it is. And there is our differential. So you could have just done that, and that would have got you to the function as well, which we need to draw. Anyway, that's how you would draw that. You could do, as I say, just find the turning point there, note it goes through there, note that it is negative, it must be on the slope here. I don't think they're going to worry too much about where it crosses here. But if they do worry about it and you did want to include that detail, then you would want to include that intercept, this intercept, and the equation of this line, which is the gradient function line of negative 2x minus 6. And that's what I would do.